Okay, so coming to the second example, again, in the second example, it requires us to find the local extreme values for the function that is given to us as y squared minus x squared. So now we're going to check its critical number, find its critical number, sorry, and then check whether it has got local extrema or not. So for finding the critical numbers, again, we need the first partial derivatives of this function. F sub x, that means the derivative of this function with respect to x. So we consider y as a constant, and then the derivative of this one becomes minus 2x. And we also need the derivative of this function with respect to y. So we consider x as a constant number, and then the derivative of this one becomes 2y. Then we are equalizing the first derivative of the function to 0. Okay, so f sub y and f sub x equal to 0. This gives us minus 2x equal to 0, and from here I get that x is equal to 0. The same thing here, if I set f sub y equal to 0, that means 2y is equal to 0. So from here I get that y is equal to 0. And from this I get that the point that I work on it, that I have got, the critical number is 0, 0. So 0, 0 is the critical number for this function that we have got. Of course, for the first partial derivatives, we do not have any number that makes the first partial derivatives undefined. So we only have got the case when we equalize them to 0. Now we need the second derivative. For what? For checking the local extreme values. So we need f sub xx, okay, the derivative of f sub x with respect to x, that's minus 2. And we need f sub yy, the derivative of f sub y with respect to y, that's equal to 2. And we also need f sub xy or f sub yx. We said since it's continuous, it doesn't matter whichever you're finding. That means the derivative of f sub x with respect to y, which gives me 0. If you look at here, we get f sub xx. We always have to check it. It is less than 0. Now we are going to check with the discriminant to see whether it is greater than 0 or less than 0 to find the local extrema. So now we are checking this, the discriminant. So I have got as a discriminant f sub xx multiplied to f sub yy minus f sub xy squared. This gives me what? This gives me f sub xx is minus 2, f sub yy is 2, and minus 0 squared, which gives me minus 4. Minus 4 is what? Minus 4 is less than 0. So the discriminant is less than 0. So we have got this case here. So when we have got this case, when the discriminant is less than 0, we do not even care about this thingy. Okay, whenever we get that the discriminant is equal to 0, f1 is less than 0, so we simply say that the critical number that we have got, so here we are writing, so the critical number 0, 0 is a saddle point. Okay, so we do not have max value, min value, we only have got saddle point. That's what? Example 2. Now let's move to example 3. Again, here we have got this function, and it is required from us to find the local extreme values of this function. So as a function, let's write it on the board so that we can solve it together. We have got f of xy is equal to xy minus x squared. Let's write it here. Okay, so the example that we have got is f of xy, that's equal to xy minus x squared minus y squared minus 2x minus 2y plus 4. So we're having the solution again, finding first partial derivatives f sub x and f sub y, and then we are equalizing it to 0. When we equalize these functions to 0, the first partial derivatives, we cannot get the value of x and y directly from these partial derivatives, okay, from this one. In the previous examples, it was not like that. We were getting the values of x and y directly, but here we cannot get it. So since we cannot get it, here we have got two equations with two unknowns. So we are managing those two equations and solve them simultaneously. You can solve those two equations in whichever method you like. For example, substitution method, elimination method, matrix method. You've studied all of the methods for solving two equations with two unknowns, so it will be easy for you. Here I'm using elimination method. Here if I write, or we can use substitution method also. Here I can write this one as y. I will just like manage it, okay, minus 2x plus y, that's equal to 2. I took that to the other side and reordered the equation, so it becomes minus 2x plus y equal to 2. And here I have got, in the second equation, I have got x minus 2y, that's equal to 2 again. So I can multiply this equation by, or let me write it here, I can multiply this equation by 2 using elimination method. What do I get as a result of those two? I get minus 2x plus y, that's equal to 2. And here 2x, multiplying this, it becomes minus 4y, and that's equal to 4. Okay, 2 multiplied 2x, that's 2x. 2 multiplied to minus 2y, that's minus 4y, and 2 multiplied to 2, that's equal to 4. Adding those two equations, what would I get? I will get, as a result of those two, x's will equal to 0, and the y will equal to minus 3y, okay, and that's equal to 6. From here, I get that y is equal to minus 2. So since y is equal to 2, putting that y equal to 2 into that equation star, so here I would say put y equal to negative 2 into equation star, okay? It doesn't matter however you're expressing this idea. المهم you're finding the solution. So here I will get x minus 2 multiplied to minus 2 minus 2, that's equal to 0. And from here I get that x is equal to minus 2, because minus 2 multiplied to minus 2 is minus 4. Sorry, it's equal to 4. 4 minus 2 is equal to 2. Taking it to the other side, it gives me x equal to minus 2. So the critical number that I have got, x and y, is equal to minus 2 and minus 2. So here in that example, the way of solving the, or let me say the way of finding the critical number was different from the ones in the previous one, because we couldn't get the value of x and y directly. After finding the critical number, what do we need? We need the second partial derivatives, as you know, okay? After finding the second partial derivatives, we need to check with the discriminant. What is the discriminant again? F sub xx multiplied to f sub yy minus f sub xy squared, which gives me f sub xx is minus 2, f sub yy is minus 2, minus f sub xy is 1. So here I get 4 minus 1, and that's equal to 3. 3 is greater than 0. So when we have got 3 is greater than 0 and f sub xx is less than 0, okay, this one is less than 0, what do we get? We get that the critical number, minus 2 and minus 2, is local maximum according to the theorem that we have got. So that was the result of the example 3.